Hello students, I am Kadambinee Balkrishna Patil, teacher in mathematics, presently working with Deccan Willingdon College, Sangli. Okay, we have started with our topic indefinite integration and we came across exercise 3.2a. So you take your notebooks and books so that we'll solve the next examples here. Okay, now our next example, that is nothing but integral of x square plus 2 upon x square plus 1 a raised to x plus tan inverse x. Now look at here. This one is very important. Why? Because in the power function you are having inverse trigonometric function. So we need to substitute for x e plus tan inverse of x. Okay, for that substitution we require t. So look at here, this is your example, that is I equal to integral x square plus 2 upon x square plus 1 a raised to x plus tan inverse x dx. So our substitution says that, just now I told you that this is an exponential function whose power is in inverse trigonometry. So we'll write that as t. So x plus tan inverse x equal to t. By differentiating, what is the differentiation of x? Differentiation of x is 1. What is the differentiation of tan inverse x? Differentiation of tan inverse x is 1 upon 1 plus x square. Okay, dx equal to dt. Here we'll take the LCM, so that 1 plus x square plus 1 upon 1 plus x square dx. This side we need to simplify. So you will get dx equal to dt. That means what? This is x square plus 2 upon x square plus 1 dx equal to dt. Look at your now integrand. What it is given? You are having this function, okay, x square plus 2 upon x square plus 1 along with dx. So this function gets simplified, and this simplification says that this is equal to 1 plus x square. This just now I have discussed about the simplification. That is, you have to take the LCM. You will get x square plus 2 upon 1 plus x square dx equal to dt. So you will get your integration as integral a raised to t dt. So a raised to t dt, directly you are able to use the formula a raised to t upon log a plus constant of integration. Now here replace your value of t so that your function becomes I equal to a raised to x plus tan inverse x upon log a plus constant of integration. These are the few examples which are based on the direct method. You can say it is a direct method. So seventh example now, e raised to x into log sin e raised to x upon tan e raised to x dx. Now look at here. There is a log function, there is a trigonometric function, there is an exponential function. Okay. Now you will come to know that e raised to x you will get immediately, because derivative of e raised to x is e raised to x. But by substituting only about e raised to x, your function will not be simplified. So we need to simplify our function. So by substituting for the tan, you start thinking in the reverse way. Then only you are able to solve this problem. Now look at here. If you will substitute for tan, e raised to x is there, it's okay. But for the tan derivative, you will get sec square, which is not in your function. So that means there is no chance of substitution for tan e raised to x. Now we left with only to substitute for the log sin e raised to x, because it's a composite function. So you have to take log sin e raised to x together. And we'll start thinking whether our function is able to find out the remaining values. E raised to x is already there, even though if you will substitute log of sin of e raised to x. Now look at here. What will be the derivative of log? Derivative of log is 1 upon, as it is, whatever inside the log function. Okay, then you have to differentiate, because this is a composite function, you have to differentiate the function of a function. So you need to differentiate sine also. So it gives you cos of e raised to x, and then you need to differentiate e raised to x, which gives you e raised to x. So already you have e raised to x, but this is cos upon sine, means it is cot, but you are having tan. So take this tan to the numerator, it converts into cot. Okay, so that function will be simplified. That means what? Now you need to substitute only for log of sine e raised to x and take the tan to the numerator. That is our step. So we'll begin with our step. So look at here, this is your integration e raised to x log of sine e raised to x upon tan e raised to x dx. Just now we are discussed that we want tan on the numerator. So we'll write 1 upon tan, because we don't want tan in the denominator or any function in the denominator. So we'll write that as log of sine e raised to x cot e raised to x dx. Now this is like a proper function. So we'll substitute log of sine e raised to x equal to t. So differentiation gives you that this is nothing but 1 upon sine e raised to x. Then differentiation of sine gives you cos e raised to x. E raised to x derivative is e raised to x. Dx equal to dt. We'll write in a proper form. So you will get this as cot e raised to x dx equal to dt, means you got this function, and this function you are able to replace by dt. So what will be the value? Value says that I equal to integral t dt. As usual, this is t square upon 2 plus constant of integration. So half will take as it is, and whatever is the t value, that you have to replace here, which gives you log of mod sine e raised to x bracket square, which is your final answer for this 7th question. Okay, so now next is e raised to 2x plus 1 upon e raised to 2x minus 1. Here addition and subtraction is not a problem, because if you add and subtract, you are not able to simplify this function. Since it is e raised to 2x, that is multiple angle, or the variable is multiplied by 2. Then what way we will simplify this? Because we are able to simplify this only by taking single power of x. That means e raised to x or e raised to minus x. Are you able to convert this function? Yes, we are able to convert. By what? You have to divide numerator and denominator both by e raised to x. Okay, so we need to divide. So e raised to 2x plus 1 upon e raised to x. Okay, we'll divide by e raised to x to the numerator and the denominator, so that we'll get our value e raised to 2x minus 1 upon e raised to x. Now separate, you will get this as e raised to 2x upon e raised to x plus 1 upon e raised to x divided by e raised to 2x upon e raised to x minus 1 upon e raised to x. Now look at here, this is simplified form, which gives you e raised to x. Okay, this is the indices law we are using here, plus e raised to minus x upon e raised to x minus e raised to minus x. Here we are using the indices law, so this function will be reduced to e raised to x plus e raised to minus x upon e raised to x minus e raised to minus x. Okay, so we'll start with our function. Okay, we'll start with the next example. Your next example is integral e raised to 2x plus 1 upon e raised to 2x minus 1 dx. Okay, as this function is e raised to, that means exponential function, we need to simplify this function. So we'll simplify this function first, that is e raised to 2x plus 1 upon e raised to 2x minus 1. We don't want the 2x for both numerator and denominator. So we'll divide by numerator and denominator by e raised to x. So that we'll get e raised to 2x plus 1 upon e raised to x divided by e raised to 2x minus 1 upon e raised to x, which is equal to e raised to 2x upon e raised to x plus 1 upon e raised to x divided by e raised to 2x upon e raised to x minus 1 upon e raised to x. So which gives you e raised to x plus e raised to minus x upon e raised to x minus e raised to minus x. So this value is of e raised to 2x plus 1 upon e raised to 2x minus 1. This value will keep for ourselves, which we'll write here. Okay, we'll start with our example. Our example says that it is equal to I equal to e raised to 2x plus 1 upon e raised to 2x minus 1 dx. Divide numerator and denominator by e raised to x, which gives you e raised to 2x plus 1 upon e raised to x, e raised to 2x minus 1 upon e raised to x dx. Now look at here, this value we already got. Okay, so this is the replacement of your function, that is e raised to x plus e raised to minus x upon e raised to x minus e raised to minus x. Now this is in the form of integral f dash x upon fx dx. For that we must know what is the derivative of the denominator, because fx is in the denominator. So we'll discuss that derivative of e raised to x minus e raised to minus x. Now look at here, you know that e raised to x derivative as it is e raised to x minus into e raised to minus x derivative is minus e raised to minus x. This minus and this minus becomes plus, which gives you e raised to x plus e raised to minus x. This is your f dash of x, which is the term on the numerator. So it is in the form of integral f dash of x upon fx dx, which gives you the result log of mod of fx. Okay, so from this result what you will get? You will get this as log of mod of e raised to x minus e raised to minus x plus constant of integration. Okay, this way we are finished with this example. We'll continue with the next example, that is sin raised to 4x into cos cube x dx. Now here is, that is the combination of both the trigonometric ratio and they are derivative of each other. That is main thing. Now thing is that if you will replace sin square by 1 minus cos square or cos square as 1 minus sin square. So here we'll start thinking which power is important. Now if you will substitute for the sign, you know that while you are taking the derivative, you will get cos x dx, and here you are having odd power of cos. This way you start thinking where to substitute, that is also important. Why you need to substitute only for the sign, that is important. Why? Because if it is a power of sine function odd, then you select to substitute cos function. So vice versa, here you are having even power for the sine function. So we start thinking in that direction, that we need to substitute for the sine. That means cos cube will be converted into sine. But what way you will convert into sine, because this is an odd power. So I will write cos cube as cos square into cos. Okay, now I know that cos square is 1 minus sine square. And this cos I want it. Why I want it? Because if I substitute for the sine value t, I know that its derivative is cos x dx equal to dt. So this will be merged in cos x dx, and immediately this function will be simplified. So in that direction, once if you started thinking, we'll start with our example. So what is an example? Example says that I equal to integral sin raised to 4x into cos cube x dx. Now I will write this as sin raised to 4x, as I told you that I need to split cos cube, that is cos square x into cos x dx. Okay, now we'll use the identity sin raised to 4x 1 minus sin square x cos x dx. Now multiply by sin 4x. That gives you, here if you multiply, you will get this as sin raised to 4x minus sin raised to 6x. Okay, and cos x dx. Now substitute. Substitute sin x equal to t. Differentiating gives you cos x dx equal to dt. And as usual also you are able to substitute. Either you multiply here itself or you begin with the example and there you need to substitute. So now look at here. You need to substitute here. So you will get sin x raised to 4. So t raised to 4. 1 minus t square dt. Now multiply. If you multiply here, you will get integral t raised to 4 minus t raised to 6 dt, because you are multiplying and this is a power indices law. So powers are added. So you will get t raised to 4 minus t raised to 6 dt. It's inside the bracket. So you separate out. If you substitute here also, you will get this integral of t raised to 4 minus t raised to 6. By this method also you are able to solve. Either you multiply here and simplify, or you simplify and then multiply. One and the same thing. Now look at here, this is integral of t raised to 4 dt minus integral of t raised to 6 dt. We are using the formula x raised to n dx. Okay, so what is that formula? X raised to n plus 1 upon n plus 1. I am writing this formula every time. That means you have to write every time that formula. So that means every formula, so that it will be in your mind while giving the exam. So write again and again the formula. So you will get your final answer as, what is your final answer? This is t raised to 5 upon 5 minus t raised to 7 upon 7 plus constant of integration. This is the value of integration. By resubstituting, you will get sin raised to 5x upon 5 minus sin raised to 7x upon 7 plus constant of integration. Okay. So this way this function is simplified. Now next example. Next example is again, now it is a combination of linear function, or you can say polynomial and trigonometric function. But how to solve this? This is very easy to simplify. Only thing is that you need to substitute x raised to 10 as something. You know that you will get the derivative as x raised to 9. So here only you will get dt. So we'll start with that. So what is it? I equal to integral x raised to 9 into sec square x raised to 10 dx. Okay, now substitute for x raised to 10 equal to t. By differentiating, you will get 10 into x raised to 9 dx equal to dt. We are having only x raised to 9 dx. So take 10 to other side. It becomes dt upon t. As 10 is a constant, it doesn't differ the integral. So we'll write here. So we'll substitute whatever value we got. That is integral of sec square t dt upon 10. 10 is the constant. So we'll take 1 upon 10 common. Integral sec square t dt. Okay. Integral of sec square t dt. So what is integral of sec square t dt? Integral of sec square t dt is tan t upon 10, because 10 already you have plus constant of integration, but resubstitute the value. So you will get your value as tan of x raised to 10, because this is tan of x raised to 10 upon 10 plus constant of integration. This is complete angle x raised to 10. Okay, so this completed your 11th question. Now we'll start with the next question, that is e raised to 3 log x, x raised to 4 plus 1 raised to minus 1 means it goes to the denominator. Okay, so here is your integral, that is e raised to 3 log x, x raised to 4 plus 1 raised to minus 1 dx. So what way we'll write? It goes to the denominator, as the indices law says that power is negative means it goes to the denominator. And we are using log function here, m log n. What is m log n? This is nothing but log of n raised to m that we are using. So you will get here as e raised to log x cube. Now here is also same base. So if you will have the base same here, e and e, log to the base e it is actually. So if it is log to the base e, that means the function as it is. So you will get, this is like log of e m. So you will get this value is equal to m. Okay. Now this way you will get here as x cube. So you will get this as x cube upon x raised to 4 plus 1 dx. Now if you will substitute for this as t, you know that you will get 4x cube dx. So 4 is constant, so you are able to adjust, but you are having a variable with power 3 which you require, so immediately you will get your values. Okay, so we'll start with that. So substitution says that 1 upon 4. Now look at here, this is nothing but your given formula. What is the formula given here? So formula says that it is equal to, this is f dash x, but this is not actually f dash x. You are having 1 upon 4. So you are able to write this as 1 upon 4 integral 4x cube upon x raised to 4 plus 1 dx. Then only you are able to use this formula, that is integral f dash of x upon fx equal to log of mod fx, and hence you will get this formula immediately, that is 1 upon 4 log mod of x raised to 4 plus 1 plus constant of integration. Okay, this way we are finished with this, the example 12th. Now we will continue with the examples. Look at the examples, that is 13, root of tan x upon sin x into cos x. Now we'll divide numerator and denominator by cos square y. My question is why? Why you have to need to divide by cos square? Because if you will substitute for the tan, you know that your derivative will be sec square, and for the sec square you need a cos square. Okay, so for that we'll begin with whatever, that is dividing numerator and denominator by cos square. Now look at here. So y2 we divide by cos square, you will get the sec square here, and here if you will divide, you know that 1 cos will get cancelled and sin upon cos is tan. Means it is a function which is in terms of tan and sec square, which if after substitution gives you the simplification as it is, because root of tan x upon tan x, that means in the denominator you will get root of tan x bracket square, so that it will be simplified. Yes, so we'll start with our example. So our example says that you have to divide numerator and denominator by cos square x. Look at here, root of tan x upon cos square x divided by, just now I told you that your integration is root of tan x upon cos square x. Okay, then in the denominator sin x into cos x upon cos square x. So 1 cos will get cancelled here. You left with upon sin x upon tan x, which is here. Okay, so here root of tan x upon cos square x sin x upon cos x dx from here, and equal to, now this is 1 upon cos square I will write as sec square. This is root of tan x as it is. Here sin upon cos gives you tan x dx. Now what is next? Next is need your simplification. What is the simplification here? That simplification is nothing but, again you need to write the power of the denominator. What is the power of the denominator? Here you are able to write as root of tan x. Tan x you are able to write as root of tan x bracket square. Okay, this gives you the same value, which is equal to sec square x dx. So 1 root of tan x will get cancelled. Hence you are getting here root of tan x dx. Now you know that this inside the root sign tan x is there. What will be its derivative? Derivative is sec square x. So put tan x equal to t, differentiating will get sec square x dx equal to dt. That means this complete becomes dt. So you will get your simplification as dt upon root t. Means what? T raised to half dt. Integral of t raised to minus half dt. Here actually it is in the denominator. So dt upon t raised to half. And it goes to the numerator. So it becomes t raised to minus half. Again we are using our formula for x raised to n. That means you have to add 1 and divide by that number. So you will get t raised to minus half plus 1 upon minus half plus 1 plus constant of integration. Okay, we need to simplify the power, so minus half plus 1. So what is minus half plus 1? Minus half plus 1 is nothing but t raised to minus 1 plus 2 upon minus 1 plus 2 upon 2. This is equal to plus constant of integration. Now this gives you 1 by 2. So this 2 goes to the numerator. Minus 1 plus 2 is 1. So you will get t raised to half. Here you are having 2, which is from the denominator's denominator. Here you are having 1 plus constant of integration. And t raised to half you will write as root t. So look at here. So your value is I equal to 2 root t plus constant of integration. The resubstitution says that tan x equal to t. So this final answer is 2 root tan x plus constant of integration. Okay. So here your differentiation, that is nothing but t raised to minus 1 plus 2. This you have to do again and again. This power, whenever there is a fraction, you try to solve somewhere that minus half plus 1, what will be the value, or minus 3 by 2 plus 1, what will be the value, or half plus 1, what will be the value. You try to solve separately somewhere in the corner, and then only you write your power here, since they are fraction. Okay, we'll stop here. We'll continue in the next lecture. Okay students, we have seen few more examples from exercise 3.2. For the remaining example, we'll meet in next lecture. Thank you.